Hello. Yeah. Good afternoon, everyone. Hope the person on the last can hear me. Just by a raise of hand. Cool. All right. Good afternoon. My name is Senthilkumar Gopal, and I hope everybody had their chocolate ice cream and ready to rock this presentation. All right. But just by a show of hands, so that we can both of us learn about each other. Are there any security professionals in here? Security software engineers, security hackers. Okay, I need to watch what I'm saying. Okay. All right. Does anyone other than the couple of folks who raised their hands know what a CIA triad is? Not the Central Intelligence, but what in software or security, what CIA means. You don't need to shout it out. Just tell me whether you know or not. Okay. One person. Okay. All right. So how many of you not heard about the recent Facebook breach? Okay, how many of you have heard about it? Almost everyone. But can someone shout out what was actually stolen? Access tokens. Okay, so now we know why we are all here, right?
Sorry, they weren't stolen, they were given away improperly.
I concede to that. I mean, it's a bug which they let it go through, and hackers were able to take it. Yes, they didn't breach anything. They didn't do anything wrong to get that information. You're absolutely right. Yeah. So let's make sure that we follow at least these 10 magical steps, as someone who walked in was telling, that we don't do the same when we develop something similar software. Okay. I'm going to tell a story as we go along, and I want to promise that this is not going to be a deep dive into cryptography or any of those parlances, but also it's not going to be really high level. I'm trying to hit a balance somewhere in between, so we are all have something to take away after this 1 hour of session. Right, so the story begins with this, right? There is a Fort Knox web application. It has been aptly named. It's impregnable, right? You will have, they have all kinds of measures put in. Obviously, this is just a play of words. They have bot checks, CSRF token verifications, model transforms, input sanitizers, and everything, right? This is a web application which pretty much will work, and they are good, and they didn't have any problems. So one night, the boss calls his most important mobile app developer and says, you know what, we have an awesome web app. Let's go and create an awesome mobile app. And he's a mobile app developer, right? Remember that. And he goes and says, sure, why not? So he sticks in a server somewhere which just talks to their databases and then does CRUD all over. And it says, OK, I am done with my mobile application. We have released, and we can have a launch party and so on. The next day, they see this happen, which is essentially their database crashes. And the boss comes and asks, what happened, right? You did every work. You're supposed to be secure. We have this Fort Knox web app. Nobody's supposed to know about it. And the answer the developer gave us, no one was supposed to know about that API server. So this is essentially a technical term called security by obscurity, which never, ever works. So when you have an API, it is given that you're going to be pushed, throttled. Hackers are going to hit millions of hits on your API with different kinds of requests, every possible type, just to see if you're vulnerable. Right? It is a given. There is no point in us assuming that just because no one knows about it, nobody's going to hack it. OK. You might ask me, come on, Senthil, that's not right. Nobody is going to do that. Nobody's going to have an API which is unprotected. Think otherwise. Just earlier this year, a big name brand did exactly that. They had an unprotected API which gave the users PII, which is their name, first name, last name, email address, and last 4 digits of their credit card, all in an unprotected API. So if you hit this URL, you will have millions of users' information just easy for you to download. And as the gentleman said, it's not a hack. They just gave it away. So our boss now is caught in this problem, and he wants to figure out, how do I fix this? Right now, my database is messed up, and he turns to the one person who can all solve this, the backend developer, or the security engineer in this case. And now our hero figures out, you know what? I don't want to do the same mistake as the mobile developer. I'm going to go and talk to an expert. And he goes and talks to an expert. And the expert says, let's talk about first basic principles of what APIs are, right? When we model a web application, we think about users. And when we model an API, we think about data. So web applications are closer to user model, whereas APIs are closest to the data model. We might say otherwise. We might say, you know what, I'm modeling my API across REST paradigms, which is based on a resource, which is based on RPC style, but at the end of the day, every API at any point of time will always be closer to your data model when in comparison to your web app. That's a given, right? So in that case, let me show you an example, right? This is a typical eBay checkout page. You will have users' information, you will have their shipping information, the item they are trying to buy, and their input, which is literally a button click. So this web app, at this time, the user has interacted with the system so many times with a standard client where we know that this is the user, this is what he has been trying to do, and these, at the final end, the input is so concise as a button click, which then transforms to a data model change, which goes through layers upon layers upon layers of security. Whereas, we take the APIs, on the other hand, we give them an ID. We say, this is the data model, this is the purchase ID you're going to do, and this is what you're going to use to update a specific record. So there's no argument that this is closer to the data model at any given point of time. So based upon these principles, the hero asks the question, so what is the first step? So the first answer is embrace the standards. Don't go create your 11th standard. Just go figure out what is the standards available, because there are better experts who have decided upon them, and let's try to use them. There are multiple of standards, and as you all know, I'm pretty sure everybody would have guessed that we're going to just pick OAuth for today. The reason why I'm doing this is we're going to look at two sides of the problem. We're going to look at what the client looks, which is the OAuth, and what the server does, which is the authorization server, right? So what is OAuth? A quick 101 is it is based upon delegated authorization. And it is based upon the concept of two types of credentials, a client credential and a user authorization. OK, too many words. Let me just quickly show you how OAuth works with a quick demo, and then we can actually read through these words. OK, let's see. Yep, here we go. All right, so this is a temporary app. I am, as a developer, I go in, and I'm saying that I want to access eBay APIs on behalf of a user. Now, as a client, when I go and register with eBay, they give me a set of credentials, which I'm going to call client ID and client secret. Obviously, this doesn't give me access to anything. Just because I have this information or this secret credential doesn't provide me information about any user at any point at all. Now, what I need to do is I need to request the user to give me authorization, right? So I, as the app developer, am the client. The user is the resource owner, because he owns the resource. And he's going to ask, so the client is going to ask the resource owner, go to the authorization server, tell me it's OK, and the authorization server will give me permission to access the API, right? Client, resource owner, authorization server. Now, I'm going to go to the authorization server, and I'm going to log in. My user ID is Senthilkumar. When I log in, oh, please work. OK. You never know with live demos, right? This is literally production. So here, the authorization server is asking the user, are you OK with giving permission to this client, the app, to access your data or to access the eBay site on your behalf? Now, if I say agree, now what does the application get back? The application gets back this weird thing, and this weird small string is what we're going to talk about for the rest of our day, right? This weird small code represents my authorization to that app saying I'm OK, which has been issued by the authorization server. Now, what does the app do? They actually exchange this temporary code to a long-lived access token, and we will see what those mean. Come on, come on, come on. OK, so Google Cloud is slow. All right, so here we go. So I get this access token, and this access token represents the application's access as Senthilkumar. It's not the application as their client ID, but this access token represents that Senthilkumar is accessing eBay via this app. And that's the three entities that we are building up. So just to demonstrate that this actually works, I'm going to search for HTMLs. Hopefully that works too. All right, cool. So this search result is returned based upon me, that when Senthilkumar searches for HTMLs, these are the results that are going to come up. So let's say if someone else, like named Barry, John, someone tries it out, it might be a different set of results. And that's what the server looks at. The server thinks that this app is acting on behalf of Senthilkumar because he did some action on that app. Okay? And this is how OAuth works. Plain and simple. Okay, going back to my presentation. Apologies. For some reason, my keynote is saying I'm not going to show up. Okay, here we go. Okay, cool. All right, so we saw two concepts, right? We have the client credentials, which is the client ID, the secret. We have the user's authorization code. If you look at it, there is a very big anti-pattern which used to happen before OAuth, which we are avoiding here. So let's say there's no OAuth in the system. If an app wants to access eBay on behalf of that user, Senthilkumar, how would they do it? They would be asking the user to provide their username and password to the app, and the app will be then providing it to eBay, acting as the user, and continuing with it. This creates an anti-pattern where the password has to be shared across multiple entities, which is a big no-no, right? You don't want to even have shared passwords for your own sites, right? So that is the pattern that OAuth 2.0 or OAuth as a system tries to address. Now, there are other systems like SAML or SSO systems which tend to do the same set of actions. But we will stick with OAuth for this session for now. Okay. It also gives you one important credibility, which is user control, right? Let's say a user feels that I don't want this app to access my data anymore, right? How do they revoke it? They can't call them and say, you know what, forget my password that I gave to you. That's not going to work. But in an OAuth system, they can actually go and say, this app has no longer control over my data, and the token which has been issued to them gets deleted or gets revoked. That's the pattern that we are trying to achieve when we are using OAuth. Okay. So we have seen enough on the client side, and this is literally the representation of what we spoke about. Resource owner going to authorization server, allowing the client to get an authorization code, exchange it for an access token, and then use it to access the resource, which is the protected resource underneath. Okay. All right, so we saw what's on the client side. Now, you might be asking, what happens on the server side, right? You spoke about all these clients, and this is the meat of the session, which is on the server side, authentication has security has multiple facets, right? Security is just not one-dimensional. It's not just authentication of the token. There's authorization. There is rate limiting. There is resource caching. Because resource caching is a means of security, because if you're going to throw the same response again and again, DDoS, you're saving yourself from DDoS, right? And so to achieve all this, you still need authentication as the first step. Why? Let's say this is an example of how Spring security or Spring rate limiting or system works, right? If you want to set up Spring security for authorization, you need to declare saying the identity that comes in, or the authentication that comes in, needs to have this authorization embedded in it. How do you know that the identity coming in is truly who they are? If you cannot authenticate your token, you cannot really trust that token anymore. So you need to ensure that your trust level on your authentication is good enough that you can suffice all the rest of the stuff, which is your authorization, your rate limiting. Everything hinges on that single piece of information, which is your authentication. So I hope I have established that authentication is important, right? Okay. All right, so the second most important step, maintain an extensible token architecture, right? You don't want to come up with a token system which cannot help out rate limiting systems or which cannot help out authorization systems. Let's say you come up with a token system which says, you know what, I cannot put scopes in it. There's no way it can have authorization scopes. We are going to have a different system for it. It's not going to work. If you're going to say rate limiting, let me take the identity of the app in a different way so that I can impose rate limiting, it's not going to work, because you need your authentication to help build other systems out. So it's like if you take a plant, authentication at its root so that it can have all these branches and fruits and vegetables on top of it. Okay, so back to our story, which is the most important thing, right? So in our story, our hero now goes to Stack Overflow, right? Because that's where we all go. right? If I don't know anything, that's the first thing we all type. So we go to Stack Overflow, and he types, how do I build a token system? And this, I'm not making this up. There's the source. You can actually go and see this answer. This is what people say when somebody says, I want to build my own token system, that you best be better smart. OK. So now our hero tries to go, talks to his expert and comes with a really big definition of what a token is, right? I would not be able to remember this. I don't think anybody would be. So I'm not, it says it's a piece of data that only a specific authentication server can come up to identify a particular entity or entities, built using different types of pieces of cryptography. OK, we're not going to look into that. We're going to take this screen. We're going to zoom into 3 of these particles that we wanted to look at. Right, so we're going to look at this one first. Identify a particular entity or entities. We already spoke about this. Right, in OAuth, we have 2 entities in place. We have the user. We have the application entity. You need to have a token representing both. You cannot have a token which represents only the user, or you cannot have a token representing only the application. There are certain caveats, but that's the common basic caveat that every token has to have both these entities embedded, without which you're an incomplete token system. OK? Cryptography, yay, the 2 people who were the security person and the 1 person who knows CIA triad, they would be happy. But the rest of them aren't. And I'm not going to go into all the details because even I don't know it. But this is kind of a 101 that we need to know for us to go through the rest of the session. So let me make it very, very easy for us to remember this. This system is called public-private key pair, or public cryptography. So I am Alice. Alice and Bob are the usual terminology which security folks use, so I'm going to use the same. I'm Alice, and there is a person called Bob. I'm going to send some information from Alice to Bob, and Bob needs to know whether it actually came from Alice, and it's not someone trying to falsify or masquerade as Alice. How do we verify that? So Alice generates a key pair, holds the private key, and sends the public key to them. So that's why they are named private key and public key. Private, you keep it private. Public, you push it out, give it to everybody else, right? Now, when Alice sends the information to Bob, she signs the data. We're not going to go into how the signing works. It's, at the end of the day, there is a big data, and you're going to generate a small signature out of that data, which is very unique to that data and very unique to the private key that you hold. And you're going to send the data and the signature along to Bob. And Bob is going to use your public key to verify whether the signature was matching. Simple as that, right? If we know this Cryptography 101, congratulations, you have passed the basic levels of cryptography, at least as part of me, right? So this is important because any token system that we're going to see from now on always kind of hinges on this basic fundamental from now, OK? There are other nuances, which is the other way around, where I encrypt using public and decrypt using private key, but let's not go into that. And there are tons of questions I'm pretty sure everybody would have. How do I verify whether the exchange was correct? How do I know the public key was sent correctly? Yes, we all know that, but let's stick with this as a 101, and this is how public-private key pair works at a basic level, right? So 2 steps out of the way. Step 3, learn the nuances of cryptography. If you're going to build your own token system without understanding cryptography, it would be really, 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 really hard for you to build it without breaking something. OK. All right. The third most important thing, specific authentication server. OK, so we're going to see specific authentication server, and there are 3 major parts to it, right? There is a lifecycle, there is a structure, and persistence. And before we go, I just wanted to see if there are any questions until now. Wow, silence. Nice. OK, so no questions? All right, so life cycle. We have already seen 2 of the entities that we love, right, that we are going to see, which was user and application entity. Now, user's life cycle is very simple, right? The user registers, they do some activity, they are inactive for some time, then they get reactivated, and then they get deleted, and they are out of cycle or out of service. But when it comes to an application, it's pretty different, because an application developer registers an app, right? They are in a registered state. When they start generating tokens on behalf of users, just like the one that I showed you, they are in an active state. And let's say one fine day this app goes rogue, They start hitting APIs for users like millions of times. Then the APIs are going to say, nah, you're not within the limit. You're going to be blocked. So they're going to stop them from hitting anything, and they'll go to block state. They might get reinstated. They might pay for a higher scale and then get reinstated, and then they'll continue to be active, or they might go into retired state. This is important because whenever you're generating a token or whenever you're authenticating a token, these are two different life cycles. You have to make sure the life cycles are embedded within your authorization server. An authorization server needs to understand the life cycle and put it into the state. So let's say one fine day our hero is going to build the authorization server for his company. He needs to embed this code or this logic into it. Same thing with tokens, right? An application can generate millions of tokens, and each token is going to take the same life cycle, which is when a user consents saying, hey, I'm OK with sharing the data with you. And then the user consents, then there is a token generator. You might see two things, an access token and a refresh token. We'll go into that in a bit. And let's say the user goes and says, I don't want this consent to be there anymore. I want this app to be kicked out of my system. And the consent is revoked. And that implies that the consent is revoked, the tokens are revoked. So that app cannot access the APIs, which is the app which I registered cannot access the eBay API as Senthilkumar anymore if I revoke my consent. Right? So these two life cycles have to be embedded as a logic into your authorization server. So anything, let's say that you allow authorizations or authentication to be performing, even for a revoked token, you're screwed because anybody can take a bunch of revoked tokens and hit your APIs and still keep getting information. OK, so we sought to, and let's put all this together. This is a very, very simple representation of it. As of now, so we're going to build this out. We're going to keep expanding this authorization server out. Right now, an authorization server gives out an access token. The client uses the access token to access and resource, at which point of time the authentication protocol embedded within the resource is going to verify the authenticity of it. OK? All right, so we saw two things. One was called a refresh token, and the other was called an access token. Now, I think the naming of it is pretty obvious, and I think they did a really good job of naming it, to be honest, because access token is simple. It gives you access to the API. And the refresh token does not give you access to the API, but rather lets you get a new access token. Because we'll see why. Let's say you gave the consent. Now, the app has your consent, but they won't get an access token which is valid for 20 years. That's a big, big no-no, and we'll see why it's a big, big no-no. They usually want to get an access token which is very, very small expiration. Maybe 5 minutes, 10 minutes, 20 minutes, it depends on your system. But you don't want to give a long-lived token. But once you give a short-lived token, how do they keep accessing your APIs on your behalf as long as they are valid, as long as the consent is valid? That's using refresh. So refresh allows you to generate a new access token. Access token allows you to access the API. Plain and simple. OK, so live the nomenclature. Like if you are building an authorization server, just like anybody would say, your code represents your domain model. You cannot have a code which represents education system not having student or roll number. Just like that, if you're having authorization server, you need to have your code representing what a refresh token is, what an access token is, what does a cryptography system mean, what does the expiration mean, and so on. OK? Right, structure. Now, this is a very, very topic close to my heart, because let's say you take a picture of a token. How many of you have actually done it? Like, if you have looked at different systems of tokens, right? Facebook, Google, eBay. I know, the three people, the three cryptographic guys, they would be so happy with it. What they do all day long, they want to see which code of it is repeatable, which code of it is giving me data enough to masquerade as someone else. But have anybody done that other than the three? If you take a picture of each of these tokens, this is how they look. They don't look similar at all, right? But they represent the same function. They are access tokens. They give you access to APIs, but they don't look similar. Now, you might ask me, come on, Senthil, is it just random strings? Do I need to go and create random strings all over? I don't want to define your new format. Please don't. There are standards which define how you want to create these tokens, at least structure this token. I don't want to say create, but structure these tokens. They're called JWT and SAML. JWT is JSON Web Token, SAML Security Assertion Markup Language. Obviously, SAML, I don't think it will, and this day will be enough for me to go through SAML, because even I don't know much about it. But JWT is a simple enough standard for us to introspect into what goes into it. How do we structure this, right? This is a very simple representation of a JWT as a JSON web token. There is a site even called jwt.io. You can go there, you can play along with it. Now, if you can recollect our Cryptography 101, this is where we're going to use it. A JWT has 3 distinct parts, which is in red, pink, and blue. Right? The red is called the header, the pink is the payload or the claim, and the blue is the signature. So if you remember our Cryptography 101, we have the private key, we have sent the public key, right? And we're going to sign our data, which is our header and payload, with our private key, and embed that signature into the token itself. So the data that we want to send out outside. So I am the authorization server. I keep a private key safe to me, and I'm going to generate a token now. When I'm generating the token, whoever receives it need to know whether it was I, the specific authorization server, who created that token. So how do I make sure of that? I generate the token. I create the header. I create the payload, put all the data inside the payload, and then I sign the data using my private key. Generate a small signature, put it at the end, which is blue in color, and the whole thing makes a token. This is what JWT's standard says. Like this is essentially the standard. There's nothing else to the standard. There are 3 parts separated by dots, and the first is the header, second is the claim, third is the signature. And this is a basic representation of what a token should have. And if you look at it, there is no system which says the claim should be of this sort. The claim should have XYZ information. There is no such standard. The standard also doesn't specify what should be the private key size of it. Like, what is the key size? Should I be 124 bits or 256 or 1024? Nothing of that sort. It can be even a symmetric key, which is a shared secret between 2 entities. Doesn't matter. But all it says is this is the structure of a token. So we're going to stick with this for the rest of our session and see where it goes. OK, so choose your token format wisely. Because if you remember our step 2, which is make sure your token is extensible, supports extensible architecture. And if you're going to go with JWT, SAML, or God forbid, with your own standard format, with your own format, make sure it supports your extensibility. Because you don't want to select something which doesn't help you with rate limiting or authorizations. OK, an obvious question is, what goes in that claim? Is there a standard to it? Again, you're coming up with all these new standards, Senthil. Just give me one more. Unfortunately, no. There is no standard which says this is what a JWT token should contain. There are recommendations saying these can contain XYZ parameters, but there is no standard of it. So what should we go into it? I kind of skipped it there. OK, so think of this parlance. You are a web app developer, right? Now you have cookies in your web application space, in your client's browser. Would you say no to any of this? Would you say no to, hey, I don't want to know who the user is. I don't want to know which IP is he from. I don't want to know which browser he's from. I don't want to know his personalized behavior. Would you say no to any of these? No. You want to know all this information so that you can make a better guess or better security when those cookies are being presented to your web app. The same thing. Web cookies are to web sessions where tokens are to service APIs. You don't want to miss anything. When you are generating a token from your authorization server, you want to capture every information possible. Obviously, there is no user agent, there is no cookie, but you will have other information, which IP the user is from, which IP the app is from, which app is generating this, the authorization scopes, which we're going to look at later, device identifiers. Let's say that you are generating a token from a mobile app. Android and iOS have these unique key identifiers which identify which device has generated it, so that when you see this token being presented from some other device, you know that token is stolen. So those are the things that you want to capture inside a token. Now, how you capture it, how we store it is a different story altogether. But a token is connected to who the user, who the app, and how they generated it. So there is incidental information, which is what the user and app is, and associated information that you want to connect. So where, how, when, what, so on and so forth, right? Now, obviously, the number of attributes that we have today might not be the same attributes that we have tomorrow. We might be adding more, we might be removing more, and please do stick a version number in it. You will thank me later. If you don't stick a version number, you're going to be stuck with backward compatibility. OK, this token is now coming in. I don't know when was this generated, and did we have the capability at that time to have a device identifier? You don't want to introspect at that time. OK, step 6. Capture every identifier possible, and please make sure you use versioning. You might ask, are we done? No, we are not. We just have one more step, persistence. And this is where I want to recollect us to the Facebook problem, right? So this was the page where they describe what happened, but this is the keynote this is the key sentence I want you guys to look at. Revoked access tokens of 90 million users, and I'm pretty sure everybody knows Facebook has around 1 billion users. So how did they achieve this, right? Obviously, I don't work for Facebook, so I cannot say how did they achieve it, but how could they have possibly did it? And let's say you are faced with a similar problem, how could you do it, right? We have a token which has all the claims, all the information. It is secure. I know this information is sent to it, and the resource API knows how to authenticate it. But there is one key information missing, right? Which is confidentiality. So the CIA triad, right? C stands for confidentiality, I stands for integrity, A stands for availability, right? Integrity is nothing but, which we already saw. Alice generates a payload for Bob, and Bob is able to know it is from Alice. That's called integrity. We already did that. Confidentiality is no one else should be able to see this information other than Bob. But this is a token, and if I give this token outside, anybody can just open the token, base64 decode it, if it's JWT, and see what is in there. Simple as that. So how do I make sure confidentiality is not broken? And how do I make sure my revocation actually works? So the answer to these two are pretty much the same. So there is the concept of something called by reference and by value. I know this is where I start stepping into a little more technical territory, but bear with me, right? By value let me give an example which one of my colleagues like. By value is like cash, right? You go to a store, you pay with cash. Nobody's going to ask, hey, who gave you that cash? Where did it come from? Is it backed by a bank? Is it backed by somebody else? Did you steal from anybody? No. So by value is by cash. By reference is your credit card. So they're going to swipe, and it's going to call the bank and say, does this guy have enough funds to back this up? Does this guy have a block on his card? Is this card stolen? That's what by reference means. So now coming back to the technical way, by value contains all the information there. By reference is a pseudonymous identifier to it. How do we achieve it? It's completely up to each authorization server. Some companies just stick the whole by value into a database, generate a random reference, encrypt it, and put it in. Some companies just encrypt the whole thing. Some companies do really to the other end. They generate new secrets for every new consent, for every user, and encrypt it with each different key. What you choose to do is completely up to you because every company has a different style. But you still want to align with the basics of by value and by reference and make sure that your CIA triad still works. Okay, so by value is integrity verified. By reference is just integrity verified, confidentiality done, and what format you choose to do it is your custom format. And just for the argument's sake of things, let's take the easier way out, which is I'm going to stick this whole by value into a database, generate a reference, and use it as my custom format. And if I'm going to build that, and this is how it's going to look like. So I have built out my specific authorization server to a little bit more. I'm going to have a relational database management system backing it up, an audit system, and a metadata server to establish the lifecycle of the app. Okay, and obviously with persistence, there are two questions. I'm kind of rushing through this because I'm definitely running out of time. And also, I'm pretty sure everybody knows what are the problems with persistences, right? You want to know which is eventually consistent and which is atomic consistency. Atomic consistency is ACID compliance, right? So think about it this way. You write to DB, and when you read the value, you want to get the latest updated value. That is the simplest definition of consistency or atomic consistency. Where do you want to have it? For new tokens, like as an app, I generated a new token, and I now present that token to your API. You cannot say, OK, come back after a few minutes because my MongoDB is still not synced from my master to slave. That's not going to work. So you need to have strong consistency for new token generation. Revocation, I put a star against it because if one user, one token gets revoked, it's plain and simple. But let's say you're on the Facebook side of things and you want to revoke 90 million users. It's going to take some time. So you decide how far or how close you want to be in terms of revocation time. But you want to be closer to atomic consistency in that. Eventual consistency can be on the other far end. It can be for auditing. It can be for cache duplication or anything else which you wanted to percolate downstream and not do it in synchronous. So just putting in a cache and then building out the systems, this is how it's going to look like. It's nothing different much from the previous one. This is just a representation of how our specific authorization server looks at step 7, which is identify our transactional needs and make sure that we are addressing all the confidentiality problems and also the eventual consistency and atomic consistency needs. Okay, very, very close to close. Just bear with me, guys. I'm thankful that you guys have been so engaged in this. Token exposure, right? And this is something which I actually added very recently to this deck, which I did some time back. So the reason why we have this deck, this step is security is literally a cat and mouse game. I'm pretty sure everybody agrees with it. We always try to be at least one step away from what an hacker can figure out, right? And when that comes into place, there is going to be an eventuality where sometimes the token is missed by the user, or the user loses their phone, or the user gets hacked in a Starbucks Wi-Fi because somebody is listening to their router. Whatever it might happen, the token system it needs to be in such a way that your window or opportunity that you're exposing should be as minimal as possible. And two key things which help you achieve that is authorization, which is scopes, and expiration. So expiration is the time up to which the token is valid, and scopes is what the token gives access to. And you wanted to make sure that the token schemes is multi-dimensional. You don't want to have one-dimensional system. Like for every third-party app, I'm going to always give a 2-day token. Or every third-party app, I'm going to give only a 1-minute token. You want to be multi-dimensional. You want to figure out, or even, I'm pretty sure the third-party developers can even be cognizant of it and say, okay, I'm going to use this on a mobile app. So give me really one-time tokens. Don't give me even multiple type user tokens. I'm going to be on a server. So give me a slightly longer one and make sure my credentials are a little more secure, or we can even use a better way of authenticating refresh to access cycles. So make sure your tokens have minimal exposure as possible. And this is a fun thing that my friends used to have is, let's say there is a token with no scopes. What do you think should be the access given to it? I'm sorry? Yeah, that's the ideal answer, sir. So I have known systems where a token with no scopes is literally the super token. It'll have access to everything because that's the default, right? So your default systems is always no. Your default systems is always fail. You never allow default systems in place. And that's definitely something you want to embed in your authorization server. If there is no scopes requested, you give a blank token. You don't give any access to it. You don't give a super token ever. All right, so allow only minimal scopes and least expiration time. And I'm almost to the close. OAuth, which is the nonprofit organization which lists all the top 10 security issues, and A2 and A10 are there, which essentially says unprotected APIs and broken session management and broken authentication, right? So there is going to be an eventual time when you will have to have a system which can do token revocation at 3 scales: for a user, for an app, and God forbid, for all your tokens, because you never know, right? So how would your system behave when you're going to revoke a user's token? How would your system act to a user coming and says, I don't want these tokens to be allowed for this app? How are you going to address that problem? If an app goes rogue, and this has happened quite often, Cambridge Analytica was a better example of it. If you want to say that I don't want any tokens given to Cambridge Analytica, I mean, I'm hoping there are no Facebook developers here to diss me out, right? So I want to revoke all the tokens for them. How do I achieve it? How do I make sure that all their tokens are revoked and doesn't bring down my system? Like, just because they have generated 1 million or 10 billion tokens, and you're going to issue, okay, update where app ID equals to this, token state equal to deleted, the whole DB shouldn't crash. So how would you address that? And let's say worst case scenario, you got hacked, which is possible, right? And you have to revoke all the tokens you have given. What is the measure of steps you want to take so that it doesn't affect your business, or at least with minimal impact, but you still have recovery time in sight? So this is a fire, at least on a partial scale, try to address what should be done to address such a scenario, which is a worst case scenario. So this is the final picture, which is we are building all this in. We're going to have a user and risk system in place which will talk to everything, which will talk to the app metadata lifecycle. It will talk to the user lifecycle, the cache system, and everything. And if the risk system knows that somebody is looking at your unprotected API just because someone released it, or somebody's looking at a token which seems to be really, really malicious, then you wanted to revoke it. And how do I do it is using a risk system in place. So audit all access pattern, and as Boy Scouts used to say, always be prepared. And step 10 is very simple. You have these many things to take care of when you're building that one single authorization server. You need to have dynamic client configuration. You need to have token lifecycles built in. You need to have cryptography rotation, because let's say you have Alice has a private key for 10, 15 years. I'm pretty sure the RSA key she had is going to be broken in the next 5 years. So you want to keep rotating the keys so that they are up to the new standard. And you want it to automate everything. Have a system in place which can automate each of these so that you don't need to build anything manually. So there you have all the 10 steps. I know I've been rushing through the slides, but all the slides and the code that I use for my OAuth tool is in there. And I'm happy to take any questions. Thank you.